Alright guys, so move to the next part, okay? And in the next part or the second part, we are going to keep on calculating the delta HRXN, but we are going to use something called the standard enthalpy of formation and the summation equation, okay? So what we learned in part 1, we learned about applying Hess's law, okay? And remember, we use these laws because we cannot use the calorimeter for many reactions, because sometimes the reactions are very slow, they will take a lot of time. Sometimes the reactions are difficult to duplicate or replicate in the laboratory, and sometimes the products, we get a lot of products that we don't want at the end of the reaction. So it's a mixture of products, not just one product, okay? So how can we find the delta H for these difficult reactions? We use Hess's law. As you can see here, we have an equation and we want to calculate the delta H, and they will give us two other reactions which we need to play with and then add to find the final delta H. So as you can see, we can just remove the 4NH3 and 4NH3 and 6H2O and 6H2O from here. If we add them, then we'll have 2O2. Why is that? Because we will remove 3 from here, and if we remove 3 from here, we will have 2 oxygens, or 2 oxygen molecules, right? So that's how we got the 2 oxygens here, and then we have 4NO going down here, and then 2N2 going down here. So we add the reactants and we add the products together, and we did not multiply anything here yet, but is this the same as this equation? No, there is another step that we need to do. We need to divide by 2, okay? So let's go here, divide by 2, and we get our answers. So when we added these, we got our answer here, and then we divide the equation by 2, and then we have our answer here, and this reaction or this equation is the same as this one, and this is the delta H, okay? Okay, so now we go and talk about the standard enthalpy of formation of compounds, okay? So the change in enthalpy when 1 mole, okay, of a substance in standard state conditions, which is 25 degrees Celsius and 1 atm, is formed from its pure elements under the same conditions. So the delta H formation is actually the heat, okay, or the change in heat in which pure elements, يعني العناصر, react together to make a compound, okay? So for example, the formation of water molecules from hydrogen and oxygen. So we have hydrogen, this is an element, عنصر, and here we have an element, and here we have a compound. So the change in this heat, the change in this reaction, the heat or enthalpy change in this reaction is called the delta H formation, or the enthalpy change of formation. Why? Because we are forming, قاعدين نكون هذا المركب من عناصره الأساسية. Okay? Also, the formation of sulfur trioxide from sulfur and oxygen. Again, هذا عنصر element, هذا عنصر الأكسجين, and then we are making a compound here, right? So the delta H is F here, formation, because we are making a compound from pure elements, من العناصر النقية. Okay? Alright. So, the standard enthalpy or the standard state of a substance means that 1 atm and 25 degrees Celsius, and it has the normal physical state at these temperatures and pressures, okay? And so on. We can skip this, you can read it on your own, okay? We'll go here. So, very important. The standard enthalpy of formation of any element in standard state is 0 by definition. For example, if we have sulfur, oxygen, nitrogen, Cl2, F2, Na, whatever, any element, the delta H F for that element is actually 0 by definition. Look here. The enthalpy change of the elements للعناصر في حالتها الفيزيائية الطبيعية under standard state conditions is actually 0, guys. So that's only for elements. For compounds, no, it's not 0. We have a number. Okay? For compounds, we have numbers. Alright? So as you can see here, this is the formation of nitrogen dioxide, and this is the formation of sulfur trioxide, as you can see. Okay? So what is true of the standard enthalpy of formation, which is the delta H note, of elements in their standard states? احنا تكلمنا على elements. قلنا انه delta HF of elements is always 0. Okay? It's always 0 for elements. And these are some standard enthalpies of formations for these compounds. You see? These are the delta HF for making 1 mole. So kilojoule per mole means we are making only 1 mole of this compound. يعني قاعدين نكون مول واحد من هاي المركبات. Okay? اللي هي هاي المركبات, as you can see. And you can see here in the reactant side في جهة المتفاعلات we have only elements. عندنا بس عناصر. We don't have compounds. Okay? And this table is important. This gives you the standard enthalpy of formation of many compounds. يعطينا حرارة التكوين لمركبات متعددة. Okay? So, yeah, you don't need to memorize it. مش لازم نحفظها. القيم هاي راح تعطاكم في الامتحان if you need to use it. So these values will be given to you in the exam to use it in the summation equation. Okay? So this is just to show you. If you notice, if you see zeros here, can you see 0? This 0 belongs to elements. هاي كلها تبعت العناصر اللي تكلمنا عليها شوي. So whenever you see a 0, it means that we are talking about an element, عنصر. إنما المركبات, but the compounds, the delta HF is not 0. Okay? And so on. So we can use these values, guys, to find the delta H of a reaction. So to find the delta H of a reaction, we learned about Hess's law, صح? So sometimes we don't need Hess's law, okay? We just use something called the summation equation. And this is the summation equation. The summation equation tells you that the delta H of a reaction is equal to the sum of the delta H formation of the products minus the sum of the delta HF of the reactants. So meaning these values here, which we will be using, okay? So what does that mean? Let's see an example. Imagine you have this reaction here, X plus Y gives me or produces Z plus R. So we want to find the delta H of this reaction. We don't know the delta H of this reaction, okay? So what we would do, we would go to the table, okay, and find X, R, Y, and Z. We will find their delta H formation. Okay, طبعا ال X, R, Y, Z are imaginary, يعني مركبات تخيلية. طبعا قيمها مش موجودة هنا، بس احنا بنحاول ان احنا نذكر بعض القيم. So we'll give them numbers. We'll give them arbitrary numbers, like random numbers. Imagine the delta HF of X is 410 and so on. Okay? So we are going to use this equation to find this delta H of the reaction. So the delta H of the reaction is going to be equal the sum of the delta HF of products. These are the products, guy, right? So we'll put this one plus this one minus the delta HF of the reactants اللي هم هني. So we use them here. So if we write the equation, it will be 570 plus 220 minus 410 plus minus 140, and we get our answer. And this is the delta H of this reaction. It's easier, way easier than Hess's law. Okay? Just to let you know, if for example, let me show it to you here. If you have 2x plus y gives me r, and the delta HF naught of x equals 100, okay, and the delta HF naught of y equals, for example, 50, and the delta HF naught of r equals 200, then when we use the summation equation, then the delta H is going to be the products minus the reactants, right? The delta HF of the products minus the reactants. So let me show you here. So the delta H of the reaction is going to be delta H F naught of R minus, now look at X here. You have 2, right? There is a coefficient. So it will be 2 times delta H F naught of X plus delta H naught F of Y. Meaning it will be 200 minus 2 times 100 plus 50. So it will be 200 minus 250, which is equal to minus 50 kilojoule, for example, if the values were in kilojoule, guys. Okay? So we need to multiply. If we have a coefficient here, we need to multiply the delta HF by this coefficient. Why? Why is that? Because the delta HF is for 1 mole. So if we don't have any numbers next to the reactions and products, it means there's only 1, so it's 1 mole. But if we have 2 or 3 or 4 or half, then we need to multiply the delta HF by that number. Okay, I hope it makes sense now. So what's the summation equation? The summation equation is this first one, products minus reactants. Okay, so let's go to an example. Use the standard enthalpies of formation to calculate the delta Rxn for the combustion of methane. So when they talk to you about the delta H formation, so the delta H formation, you know that you are going to use the summation, not the summation equation. Okay, you know that you are going to use that. So if we go, this is the reaction, guys, and we want to calculate the delta H Rxn, right? We don't know it. Okay, so basically we need to find the delta HF for these compounds or elements. So where did we get these numbers here, guys? We got them from this table. They will already give it to you in the exam. Okay? Or they will give you this table. So CH4 gas. So let's look for CH4 gas. Here it is. Can you see it? So minus 74.6. قربوها, they rounded it to minus 75. Let's look for CO2 gas. Make sure that it is gas, guys. Sorry. Let's look here. Oxygen gas. So without looking at the table, oxygen is an element, عنصر. And we said that the delta HF for elements للعناصر is 0. So the number is 0 here. If you go and look for oxygen, okay, oxygen, here it is. It's 0, guys, right? Now, CO2 gas is here. So minus 393.5, which is 394 if we round it, إذا قربناها. And finally, H2O liquid. So H2O liquid is minus 285.8. لازم ننتبه للحالة الفيزيائية liquid, solid or gas, because we have two H2O. One is liquid and one is gas. So you need to choose the one that is mentioned in the equation. It's liquid, so we'll choose the liquid, which is minus 286. So find delta H RXN. Now delta H RXN is going to be the sum of the delta H node of products minus the sum of the delta H F node of reactants. So this is going to be equal to, so what are the products? Here are the products, right? So it's the delta H F node of CO2 plus, do you see the 2 here? We need to multiply it by the delta H F node of H2O minus delta H F node of CH4. We don't have, it's 1, so we don't need to use it, plus 2 times the delta H F node of oxygen. So it will be minus 394 plus 2 times minus 286. We close this, minus the delta H F node of CH4 is minus 75 plus, we know this is going to be 0, right? All of this is going to be 0, but we'll just write it down, okay? No problem, for the sake of writing the equation. And then you put this equation in the calculator and you should get 4 plus 2 times minus 286, 75. You should get minus 891 kilojoule. So this is the delta H RXN for this reaction. Okay? All right. Yeah. Okay, guys. So this is the end of our lesson, which is lesson 4. I'll let you read these or this table. Okay, no problem. And then you have the last part in your book, which talks about acid rain, الأمطار الحمضية. It's theoretical, okay? It has to do with these compounds, sulfuric acid and sulfur trioxide, okay? This is just for you to read again, along with this. So the main idea here is to answer this question. Write down the 4 steps of the formation of the acid rain, اللي هي الأربع خطوات لتكون الأمطار الحمضية, and you have the answers here. You have this in your book, so you can read it from there, or you can read it from here, guys. Okay? All right. So this is what we covered today. We learned how to apply Hess's law to calculate the enthalpy change of a reaction, delta HRXN. We explained the basis of the standard enthalpies of formation and the table, right? We calculated delta HRXN using thermochemical equations, which is Hess's law, and the summation equation, and we determined the enthalpy change of a reaction using standard enthalpy of enthalpies of formation, sorry, the summation equations we did here, okay, the last example that we just solved, right? Okay, that's the end of lesson 4, guys. Thank you for watching the video. Again, please try to share and subscribe to the channel so that many students can hopefully benefit from the videos. And if you have any questions, you can just leave a comment or you can contact me, guys, okay? Thank you very much. I wish you all the best and take care.